Do you want to get an A on your next math assignment? Well, listen up. Today, we're going to talk to all those young mathematicians out there who have some questions about two-step equations and applying them to real-world situations. We're going to talk about some steps to solving them and even show you some cool tools to help you gain a better understanding. All of this goes along with the 7th grade Common Core State Standards, as well as the standards for mathematical practices. But what is a two-step equation? I'm so glad you asked. A two-step equation is just an equation or inequality that requires two steps to solve using two different operations. To help us figure this thing out and give us some real-world application, I want you to meet my friend, Marley.
Marley is a hard-working kid, and he doesn't mind working hard for the things he wants. Right now, he has his eye on a brand new 10-speed bicycle. He has decided to earn the money by mowing his neighbor's lawns. If the bicycle he wants costs $120 and he charges his neighbors $15 per lawn, how many yards will he have to mow in order to have enough money for the bike? In order to answer this question, Marley will set up an equation by putting together the information that he already knows. He knows that the bicycle will cost $120, and he knows that every time he mows a neighbor's lawn, he earns $15. So, 15 multiplied by the number of lawns he needs to mow, or X, should equal out to be $120. Now what does he do?
Let's ask a teacher.
Inverse operations are two operations that undo each other. For example, if we had 10 minus 6 equals 4, we could get back to the beginning by doing the opposite of subtraction, which is addition. So 4 plus 6 equals 10. So when you're looking at inverse operations, you're looking at addition and subtraction undo one another, and multiplication and division undo each other. The property of equality states the same operation must be performed to both sides of an equation in order to maintain equality. Take this equation for example. We have x plus 2 and 7 tenths equals negative 8 and 4 tenths. If we want to solve this equation by getting the x by itself, we look for what is the inverse operation of addition, which is subtraction. So we would minus 2 and 7 tenths from the left-hand side, which gives us 0. And from the identity property, we know that x plus 0 is just x. The property of equality then steps in and says that the same operation must be performed to both sides of an equation to maintain equality. Or in other words, if I subtracted 2 and 7 tenths from the left, I also need to subtract 2 and 7 tenths from the right in order to keep this equation balanced. So then I find that x equals negative 11 and 1 tenth. Another way to look at the property of equality is if you do something to one side of an equation, you must do it to the other side as well. When using inverse operations and the property of equality, what you're truly creating are equivalent equations, the equations that have the same solution. So for example, this equation we started with, x plus 2 and 7 tenths equals negative 8.4, has the same solution as x plus 2 and 7 tenths minus 2 and 7 tenths equals negative 8.4 minus 2 and 7 tenths. In both cases, the same x value, negative 11.1 or negative 11 and 1 tenth, make this equation true.
Yes, Marley needs to divide because the opposite of multiplication is division, and because dividing both sides by 15 will first isolate the x on one side and give him the answer on the other. Whatever Marley does to one side of his equation, he must do to the other side. So it looks like Marley needs to mow 8 of his neighbor's lawns in order to buy his bike. But wait, Marley needs to buy gas for his lawnmower too. Gas will cost him $30. So it looks like we need to write a new equation. Our new equation is 15 times the amount of lawns he needs to mow, or x, minus the cost of gas, for $30, which should equal out to be $120. Now we have a two-step equation. Let's break this down piece by piece. In this equation, there are two different operations at work. We have multiplication and we have subtraction. We learned earlier that we need to use the inverse operation to solve this problem. We found that the inverse of multiplication was division, and we also learned earlier that the inverse of subtraction is addition. Let's start by adding. We'll add the $30 to both sides. This will give us 15 times x equals 150. Now, let's divide both sides by 15. This will give us x equals 10. Great! Marley needs to mow 10 of his neighbor's lawns in order to buy his 10-speed bicycle. That's a lot of lawns. Better get mowing, Marley.
So Marley was able to solve his two-step equation by using both the inverse operation and the property of equality. Let's recap. Inverse operations are two operations that undo each other. Addition undoes subtraction. Multiplication undoes division, and vice versa. Next, the property of equality states that the same operation must be performed to both sides of the equation in order to maintain equality and balance. We can actually think of our equations as if they were a balance. Each balanced side holds the same weight as the other, and as we attempt to rearrange our scale or our equation to find the missing variable, we must always remember to maintain our balance. So, whatever is done to one side of an equation must be done to the other. If we can remember these two guidelines, we'll be well on our way. Now, let's take a look at some online activities that can help us grasp this concept even more. First, we'll look at the National Library of Virtual Manipulatives with the Algebra Balance Scale. Then we'll play a game, Math Play, Hoop Shoot, to help us practice our skills. So here we have our Algebra Balance Scales, where we're given an equation, and our task is to first construct our equation on our balance scale and then solve it. So our small box here with the number 1 on it represents a 1 unit, and our x represents the unit of x. So our equation says 2x plus 4 equals 6. So on this side, I need to put 2 of our x boxes, and then 4 of our 1 unit boxes. On this side, I'll need to put 6 of our 1 unit boxes. Now our scale is balanced. I'll click continue. Okay, so now I need to solve it. Let's remember our rules. So we know that we have to use the inverse operation. We know that whatever we do to one side, we must do to the other. So let's take a look at what operations we have. We have multiplication and we have addition. Okay, let's tackle our addition first. The inverse operation of addition is subtraction. So we're going to subtract. And we're going to subtract 4. Good, that worked. Now we have multiplication. The inverse of multiplication is division. So we'll divide both sides by 2. Good. So we can see that as we were dividing, both of our sides were decreasing. And now all that's left is x equals 1. And our sides are still balanced. Here's a new problem. We have 4x plus 4 equals 8. So let's first build our problem. And we see how it's not balanced at all. Okay. Now as we take a look at our scale, maybe we can see some of our own patterns before we even solve. We see that both sides each have 8 of their own pieces. So can you guess what x equals? Let's continue. We'll see if your guess was correct. So what do we need to do first? We have addition and we have multiplication. The inverse of addition is subtraction. The inverse of multiplication is division. Was your guess correct? So now we're going to play a game called Hoop Shoot. And this is actually a one-step equation game, but this will be great practice. And you can either play by yourself, with another person, or do a time challenge. So we're going to play by ourselves. Okay, and I'll be teacher. And let's say I'm a little experienced. Okay, so solve the equation m plus 24 equals 15. So what is the inverse operation? We know that we are adding. So what is the inverse of addition? Subtraction, right? So we know that we need to subtract 24 from both sides, and that will give us -9. So now I get to shape. I made it! Great! Okay, our next equation is y minus 2.5 equals -4. Again, what's our inverse operation? We see that we're subtracting, so what's the inverse? Right, it's addition. So we know that we need to add 2.5 to both sides. So what do we get when we add 2.5 to both sides? -1.5. Let's see if I can make it again. Oh, too bad. Okay, this will be our last equation that we do, and you can play on your own as much as you want. And again, this is great practice. This equation says 33 equals m plus 100. We're adding. What's the inverse operation of addition? Subtraction. That means we need to subtract 100 from both sides. When we subtract 100 from both sides, we get. See if I can make it. Oh, too bad. Maybe you'll be better at the shooting portion. Now, this concludes our journey into the two-step mathematical equation. I hope you've enjoyed this presentation. And don't forget to practice, practice, practice. Practice makes perfect. And before you know it, you'll be solving these equations in your sleep. So until next time, goodbye and thank you.